All right, so this is going to be mostly review stuff, even from this year, review stuff. But I figured that I would go ahead and do it anyways because it's going to be related to some of the stuff we're going to do later on with other functions. So first of all, how do you find the x and y intercept of an equation? What is an x and y intercept? So your x-intercept is going to be where the graph crosses the x-axis. And of course the y-intercept is going to be where the graph crosses the y-axis. So how do you find an x-intercept? Now this is the same for any function. We're talking today just about linear functions, but this will be the same for any of them. You're going to set y equal to 0 and solve for x, because then you'll get an x equals. It's going to cross the x-axis when your y is equal to 0. And if you think about that, okay, when is it going to cross the x-axis? Well, it's going to be when your y is 0. And exactly the opposite for the y-intercept. Okay. So when is it going to cross the y-axis? It's going to be when your x is equal to 0. Okay. Now, next we have the slope or the gradient of a line. So your slope formula is in your formula booklet. And again, it may call it the gradient. Slope and gradient are the same thing. Find the slope of the line that passes through the following points. Okay, it's totally up to you which point is considered the y1 and which one's considered the y2, as long as you don't switch mid-formula. I'm just going to consider this to be x2 and y2, x1 and y1, just because that's probably what you would do as well. So I have 1 minus 0, y is on top, 3 minus negative 2 on the bottom, 1 over 5 is my slope. Keep that as a fraction because here in a little bit we're going to talk about graphing, and it's going to be a whole lot easier to graph when you have it as a fraction. Now, the classification of your slopes, this would be a positive slope, which would be an increasing graph. This is negative. This is a horizontal graph, and you have a slope of 0 for that. The way that I remember that is it's flat, it's not going anywhere, so 0. And then this one is vertical, and with a vertical, your slope is undefined. And the way that I remember that is it's so steep, there's not even a number steep enough to give that. Also, kind of as an FYI, your horizontal graphs, those have an equation of a y equals a number. Your vertical equations, those are x equals a number, because it's some value on the x-axis, and it's that same x value all the way up and down. Same thing with the y. Some number on the y-axis, same y value all the way around. Now, to do graphing, you can do graphing in the calculator, but there may be some wording that you need to be able to do it by hand. So we want to talk about doing it 2 different ways. This first way, you could totally put in the calculator because it's already y equals, and that's what you want to be. That's the form you want to put it into the calculator. But the book calls this general form. We call it slope-intercept form. It is in your formula booklet, and it's in there as y equals mx plus c. So that's kind of weird because we're used to seeing that as y equals mx plus b. But it's the same general idea. So in this case, your slope would be negative 2/3. That means that we're going to go down 2, and we're going to go right 3. Then down is because it's negative. Positive would go up, negative would go down. And personally, I always go right. You could go left, but if it's negative, don't go left and down because now you've canceled out the negative. It's just one or the other. Okay, and then my c value or my y-intercept is 4. So I'm going to start on the y-axis at 4. Now, if you can't remember if it's a y-axis or an x-axis, think about, okay, well, if I plug 0 in for x, I get 4 for y. So that's a point on my graph. Now, to get other points, and this is something that you might be asked in your homework, is to give other points based off of a slope. I'm going to go down 2, right 3. That's another point. If you need more, go down 2, right 3. And you can even work backwards. Go up and left. There would be another point. And then we can connect the dots. And there's my graph. Now, if you did want to put this into the calculator, okay, we would go to our y equals here, and we would type negative 2/3. You don't have to put that in a parenthesis, but you can if you want, times x plus 4. And we hit graph. Now, to actually put this on the paper, you would have to go to your table. So second in table, and find some good values. So here's a good one, here's a good one, here's a good one. You only need 2 points, but the more points that you can get, the better. And then graph those points. Okay. Now for the next one, let's say that you can graph this with a calculator. I wouldn't, because you would have to solve it for y to be able to do that. This is an equation that's in standard form. Now this is the standard form that they use in IB. We normally don't have it equal to 0, but it doesn't matter. The idea is that x and y are on the same side. So this is way easier to use by finding your intercepts and plotting those. So if we want to find our x-intercept, remember we plug 0 in for y. So 2x 3 times 0 equals 12. Well, of course, this is just 0. So 2x is equal to 12. X is equal to 6. And then plot that point. 1, 2, 3, 4, 5, 6. Okay, it's an x-axis. It goes on the x, or it's an x-intercept that goes on the x-axis. So y-intercept, same thing. 2 times 0, 3y equals 12. That's just going to be negative 3y equals 12. And y is negative 4. 1, 2, 3, 4. And then we're going to draw a line through it. Now, one thing that's a common mistake with this is that students plot it as a single point, 6 comma negative 4. That doesn't help you, okay? And it's an x and y intercept. If you put it together, it's not an x and y intercept. Okay. Now, again, we could graph this one in the calculator, but we would have to solve this for y, which is not super simple. So I wouldn't put it in the calculator. I would do exactly what we did here. All right, next, writing equations for lines. Now, we did this earlier this year, back when we did the geometry stuff. So again, it seems kind of silly, but it has to do with the linear model part that we're getting to. You can write an equation for a line if you have at least 2 points or 1 point and a slope. Now, easiest way to do that is to use point-slope form. This is not in your formula booklet, but I think most people know that formula pretty well. It's also, it comes from slope. So if you think about the slope formula, if I multiply both sides times x2 minus x1, that's essentially this. It's just that the x2 and the y2 are just written as a y instead of a y2. So find an equation for a line that passes through the point 4, negative 3 and has a slope of negative 2. So my slope is negative 2, and my point is 4, negative 3. So y minus my y is equal to negative 2, x minus my x. Okay, sorry, I had to stop there for a minute. But that's my equation. I'm just going to simplify the minus and negative 3, and I'm going to go ahead and distribute the negative 2. They may want the equation to be in that slope gradient form or the slope intercept form, so let's continue doing that here. So y plus 3 is equal to negative 2x plus 8. So again, I simplified this right here, and I went ahead and distributed there. Y is equal to negative 2x plus 5. Okay, so for part B now, find the equation of the line that passes through those 2 points. I need a slope before I can write this equation. So my slope is going to be 1 minus 5, 3 minus negative 2, negative 4 over 5. Now, you could make that a decimal, but again, it really would be better to leave it as a fraction, especially if it was a yucky decimal. You'd want to definitely leave it as a fraction. As far as a point, pick a point. It doesn't really matter which one. I'm going to pick this point because there's no negatives, and I'd rather not deal with any negatives. So I have y minus 1 is equal to negative 4/5 x minus 3. Y minus 1 is equal to negative 4/5 x plus 12/5. Okay, when you multiply, you're multiplying 3 over 1, and you're multiplying the tops and the bottoms. Okay, we're going to add 1. Now, because we're going to need common denominators, when I add 1, I'm actually going to add 5 over 5. So I get y is equal to negative 4/5 x plus 17/5. Now, it turns out that a fifth is not a bad decimal, so you could do that as a decimal if you needed to, but there would be our exact answer. All right, now that leads us into section 4.5, which is about linear models. So for this first one here, we have a yacht that has tanks of diesel fuel that must be filled before it heads out to sea. The tanks contain 500 gallons of fuel when the yacht arrives at the fueling dock. The diesel is pumped into the tank at 40 gallons a minute. We're going to write a function d given the total volume of diesel in the yacht's tanks after t minutes of pumping fuel. Okay, so here's what we're hoping. We're hoping we can write an equation in this form. And I'm going to write C just because that's what the IB formula booklet does there. But C is my initial whatever. In this case, the tanks contain 500 gallons of fuel when the yacht arrives. So my y-intercept, or my C value, would be 500 gallons of fuel. The slope is the rate of change. So in this case, the diesel is being pumped at 40 gallons a minute. So 40 gallons in 1 minute, that's my slope. So my equation is 40x plus 500. Now we're supposed to be doing this d in terms of t. So really that's going to be d, and really d of t would be the best way of writing that. 40t plus 500. Now, you could try that out. Think about you're doing 40 gallons a minute. Okay, so after 1 minute, you would have 40 plus 500, 540 gallons. Is that what you would have? Yeah, I mean, reading the example there, yeah, you start off with 500, so after 1 minute, you would have 540 gallons. Okay, so D of 30, what does that value represent? Well, this is going to be the amount of fuel, or if you want to be specific, diesel, after 30 minutes. So 40 times 30 plus 500 is 620 gallons. No. How about, I was trying to do that in my head and didn't do it big enough. That's going to be 1,200 plus 500. That's going to be 1,700 gallons. And again, that's after 30 minutes. Okay, how long will it take to fill the tanks if the tanks have a capacity of 2440? Okay, well, 2440 is equal to 40t plus 500, and we solve. So we subtract 500, that's going to give me 1940 is equal to 40t, so t is 48.5 minutes. Now, finally, what is the domain and what is the range of the function? So this is a line. So if you drew a picture of a line has a domain of all real numbers and a range of all real numbers. But in this case, it doesn't make sense for that to be the case. For example, my domain are my t values, which is my time. You can't have a negative amount of time. Also, this tank has a capacity of 2,440 gallons, and that happens at this amount of time. I can't have a time that goes past that. So my domain is going to go from 0 to 48.5. Or 0 is less than or equal to t is less than or equal to 48.5. The range of the function, in this case, the lowest amount, okay, so my range has to do with how many gallons I have. The least amount of gallons that I can have is 500 gallons because that's how much I have initially. That's for this scenario. Obviously, a tank could be empty, but that's not the case for this scenario. The most that I could have is that capacity. So we're going from 500 to 2440, or 500 is less than or equal to D is less than or equal to 2440. Okay. All right, finally, we want to write an equation based off some data. Now, you might be given a table of data. They don't really have you put those numbers into the calculator and do a regression the way that we did before. They're really wanting you to do this by hand. Could that be done? Yes, but that should be the easier way of doing it, so I want to make sure we can do it the harder way. And then maybe at the end here we can remind ourselves of how to do this on the calculator. So the life expectancy of a female in 1970 was 74.6 and in 2000 was 79.7. We're going to write an equation, E of t, where t is the number of years since 1960. That's kind of an important thing there. Okay. So we're going to write points out of our data. So in 1970, the life expectancy was 74.6. But they want me to write the equation so that t is the number of years since 1960. So 1970 is 10 years since 1960. And 2000 was 79.7. That is 40 years since 1960. So those are my 2 points there that we're going to use to write our slope out. Now, I didn't really give you enough space up here to do this, so I'm going to kind of go down below B as I work this out here. So my slope is going to be 79.7 minus 74.6 over 40 minus 10. So that's going to be 5.1 over 30. This would be one that would be totally acceptable to go ahead and make be a decimal. Now, you could simplify this. If I take the top and the bottom times 10, I get that. Now that doesn't simplify. So these are the same thing, okay? And let me double check here if that came out to be exactly 0.17. It did, okay. All right, so now that's my slope. Pick a point. I'm going to use the point 1074.6. I just picked that because it was the smaller one, and that's what I already had done on my paper. So we're going to have y minus 74.6 is equal to 0.17 x minus 10. Okay, go ahead and distribute here. And then 0.17x, add 74.6, 72.9. Oh, except we used x and y, this should be E of t is equal to 0.17t plus 72.9. They might take points off if you don't do that on the exam, so I would try to make sure that you do put it in the letters that they use there. Now, use the equation to predict the life expectancy of a female in 2020. Okay, so in this case, 2020 would be how many years since 1960? That would be 60 years. Just subtract. 2020 minus 1960 is 60. So E of 60 would be 0.17 times 60 plus 72.9. We end up with 83.1 years old. Now, if you did use the calculator to do this, let me show you how that would look just as a reminder. Okay, so we need those points, and we would go to Stat, and we would go to Calculate. So, I'm sorry, we would go to Edit. I need to put my data points in. So I'm going to go up here to List 2, and I'm going to hit Clear, not Delete. Hit Enter to clear that list out. I'm going to go up here, hit Clear, not hit Delete, hit Enter to clear that list out. I'm going to put my X values in, which are my years. So I only have two, 10 and 40. Okay, now some of the ones that you have in your homework, they have a whole table. So you could put that whole table in. But like I said, I think on those they're giving you a certain criteria of which numbers to use. This is really going to be for when you're not sure which points to use. But if they're telling you which points to use, then you don't have to worry about that. Okay, I put my Y values in for list 2. Okay, and then we're going to go to calculate. back on stat. Everything's on stat. Stat edit is where you put in your numbers. Back to stat again, calculates where I'm going to get my equation. And we're going to go down to number 4. Now there are 2 linear regressions, but you always want to pick 4 because of that AX. I don't know what the difference is really between the 2, but that's always the one that we want. Okay, that screen should match. My X's are my list 1, my Y's are my list 2. We're going to come all the way down here. If you don't have this screen, just go ahead and hit enter because there's no reason. It's going to do, this is the kind of default setting anyways. Okay, we hit enter there. And those values are the same values that we had. So you're going to just fill this in here. That's going to be y is equal to 0.17x plus 72.9. That's exactly the same equation that I came up with. Now, as far as predicting that value there for x, just plug it in. You could go to your table and look for it in the table, but that's more trouble than what it's worth. Okay. If you need some help with the calculator stuff, let me know. Like I said, I don't really think that's something that they want you to do in this section, but in general, it is something you're going to have to be able to do potentially on the exam.